Imagine a thread, so thin you can barely see it, so light it could circle the earth and still weigh less than a suitcase. Picture holding it in your hand. It's almost invisible, yet it stretches on and on, defying your expectations of what something so delicate could do. This is not just any thread, it's a marvel of the microscopic world, a testament to how the tiniest things can hold unimaginable power. Yet this thread is hundreds of times stronger than steel. It can withstand forces that would snap metal like a twig, and it does so while remaining feather-light. Imagine the strongest bridge cables, the toughest armor. This thread could outperform them all, and do it with a fraction of the weight. This isn't science fiction, it's real. It's called the carbon nanotube. Born from the world of nanotechnology, carbon nanotubes are cylinders of carbon atoms, only a few billionths of a meter wide, yet they possess properties that seem almost magical. Sometimes the biggest revolutions come from the smallest things. Throughout history, tiny discoveries have changed the course of civilization. Fire, the wheel, electricity. Now, the carbon nanotube stands poised to join that list. Our ancestors mapped the stars and crossed oceans. Today, we explore the atom. The spirit of discovery that led us to new continents now drives us to unlock the secrets of the universe at the smallest scales. In this microscopic world, we found a building block that could reshape everything. Carbon nanotubes are not just strong, they're flexible, conductive, and incredibly light, opening doors to inventions we've only dreamed of. A tiny, rolled-up sheet of carbon atoms, stronger than anything we've known, challenges us to dream bigger. It's a material that invites us to rethink what's possible, to imagine structures and machines that were once pure fantasy. The story of the carbon nanotube is a story of human curiosity and ambition. It's the next chapter in our quest to build, to innovate, to reach beyond our limits. For millennia we built with wood, stone, and metal, always limited by their strength. Every era was defined by the materials we could master, and every breakthrough pushed us further. But what if those limits vanished? What if we had a material that was almost perfect? Imagine skyscrapers that reach higher, vehicles that are lighter and faster, and technologies that seem to defy gravity itself. Carbon nanotubes force us to ask, what could we build if we had no limits? What new frontiers could we reach if our materials were as strong as our imagination? Let's journey into the nanoverse to a scale 100,000 times smaller than a human hair. Here, the rules of the ordinary world no longer apply, and the extraordinary becomes possible. We'll see carbon atoms link in a perfect hexagonal lattice, forming a structure with extraordinary properties. This is the architecture of the future, built atom by atom. Imagine a thread strong enough to lift us to the stars. A single strand, woven from the fabric of the universe, could one day connect Earth to the heavens. The cosmos is waiting. The next leap in human achievement may begin with something impossibly small, yet infinitely powerful. Let's begin. What is this miracle material? It's not some rare element or a substance from a distant galaxy. In fact, it's something you've probably held in your hand countless times, maybe while sketching, writing, or doodling in a notebook. To find it, just look at a pencil. The lead inside isn't actually lead at all, it's graphite, a form of pure carbon. This simple everyday material is the gateway to some of the most extraordinary science in the universe. Carbon is everywhere. Floating in the air is carbon dioxide, woven into the food we eat, and encoded in the very DNA that makes us who we are. It's the backbone of life, the foundation of organic chemistry, and a key ingredient in the fabric of the cosmos. Now, imagine peeling off a single, impossibly thin layer from that graphite, a sheet just one atom thick. This is graphene, a marvel of nature, a flat, honeycomb lattice of carbon atoms. If you roll that sheet into a seamless, microscopic cylinder, you create a carbon nanotube. It's cosmic origami, simple, yet profound. No exotic ingredients, just pure carbon atoms arranged with mathematical precision. The magic lies in the geometry, in the way these atoms connect and fold. The way these atoms bond in a tube gives rise to astonishing properties: strength beyond steel, conductivity rivaling copper, and flexibility that defies belief. It's a perfect example of how simple rules, repeated at the smallest scales, can create complex wonders that change our world. So, when you hear carbon nanotube, don't picture something impossibly complex or out of reach. Instead, think of a pencil, a humble tool, and imagine a single layer of carbon atoms curling into a tiny, perfect tube. That's the heart of this material. You're picturing one of the most advanced materials ever made by science. The universe packs immense potential into its smallest building blocks, waiting for us to discover and harness it. All we need is curiosity and a willingness to look closer at the ordinary, to unlock the extraordinary. Why are carbon nanotubes so exciting? Because they excel at almost everything. Pound for pound, they're the strongest material we found, hundreds of times stronger than steel, but a fraction of the weight. They're also exceptional conductors of electricity. Electrons zip through them with almost no resistance thanks to quantum mechanics. Depending on how you roll the graphene, a nanotube can be a metal or a semiconductor. They're also among the best thermal conductors, far surpassing copper or silver. This means they can whisk heat away from electronics with incredible efficiency. Imagine a material that's strong, light, conducts electricity and heat, and can be tailored for electronics. It's not just an improvement, it's a quantum leap. The universe has handed us a new set of tools. Let's try to grasp just how extraordinary this strength is. Imagine a thread as thin as a single human hair, so delicate you can barely see it. Now picture that thread made from carbon nanotubes, and believe it or not, it could support the weight of an entire car dangling in mid-air. This isn't science fiction, it's the reality of what's possible with these remarkable materials. The secret lies in the atomic structure. Perfect carbon-carbon bonds arranged in a flawless, seamless hexagonal lattice. This arrangement gives carbon nanotubes their almost unbelievable strength. There are no weak points, no cracks, and no imperfections, just atomic-level perfection that resists breaking, even under extreme stress. Nanotubes aren't just strong, they're also incredibly resilient. They can bend, twist, and flex, then spring right back to their original shape, making them ideal for demanding applications. Today, we're already using nanotubes to reinforce plastics and metals, creating advanced composites that are not only stronger but also much lighter than traditional materials. This technology is transforming sports gear. Tennis rackets, bicycles, and even baseball bats are becoming lighter, more durable, and more powerful thanks to the integration of carbon nanotubes. But the impact goes far beyond sports. Imagine entire aircraft and spacecraft built from these advanced composites, lighter, more fuel-efficient, and dramatically cheaper to launch into space. Car bodies could be as strong as steel, yet as light as plastic, revolutionizing automotive design and efficiency. Wind turbines built with carbon nanotube composites could capture more energy, last longer, and withstand harsher environments, helping us harness renewable power more effectively. This isn't just about better sports equipment or faster cars, it's about building a more sustainable, efficient, and innovative world for everyone. The strength of carbon nanotubes is impressive, but their electrical properties could be even more revolutionary. Electrons flow through them almost without resistance. Ballistic transport, replace copper wires with nanotube cables, and we could save massive amounts of energy, lost as heat. In electronics, nanotubes could replace silicon, making transistors smaller, faster, and more efficient. Imagine computers hundreds of times faster, smartphones that last weeks on a charge. This isn't just about speed. It's about unlocking new possibilities for AI, medicine, and climate science. The flow of electrons through these tiny tubes could power humanity's next leap. The most audacious dream inspired by carbon nanotubes, the space elevator. Picture a cable stretching from Earth's equator to a satellite in geostationary orbit. 36,000 kilometers up, robotic climbers would ascend the cable, carrying cargo and people into space. For a century this was pure fantasy, no material was strong enough. But carbon nanotubes changed the math. In theory, they're strong and light enough to make it possible. A space elevator would slash the cost of reaching orbit, making space accessible to all. We could build solar power stations in orbit, giant telescopes, and even bases on the Moon and Mars. The space elevator would be a permanent link between Earth and the cosmos, a true ladder to the heavens. If carbon nanotubes are so amazing, why aren't we using them everywhere? The answer: manufacturing. Making perfect nanotubes in bulk is incredibly hard. Current methods produce a jumble of tubes, different sizes, shapes, and properties. Separating and assembling them into flawless cables or sheets is a monumental challenge. We can make millimeter or centimeter long tubes, but we need thousands of kilometers for a space elevator. Scientists are working to control growth and purity, but progress is slow. Every breakthrough brings us closer to unlocking their full potential. The carbon nanotube revolution has already begun. Companies are producing nanotubes for real-world products, fuel lines, electronics, and more. These early uses may not grab headlines, but they're crucial. Nanotubes are improving batteries and supercapacitors, helping devices charge faster and store more energy. Better batteries are key for clean energy and electric vehicles. We've gone from lab-scale milligrams to industrial tons. Each new product and process teaches us more. These first steps are building the foundation for even greater breakthroughs. We've explored the atom and discovered a material of mythical properties. We've dreamed of lighter vehicles, faster computers, and a bridge to the stars. But the biggest challenge is still ahead, turning lab discoveries into world-changing technology. The story of the carbon nanotube is still being written. Each new material has reshaped society. The Stone Age, Bronze Age, Iron Age, Silicon Age. Now, we may be entering the Carbon Age. The universe has given us the thread. What will you build? What problems will you solve? The rest is up to you. Your imagination is the only limit.